Bam, Mr. True. Let's keep going with our evaluating trig functions using half and double angle identities. And then part 3 and maybe part 4 we'll do some proofs using identities, the half angle and double angle identities. Okay, so we got the cosine of negative 3 pi over 8, and I want to evaluate that on the unit circle. I want an exact value answer, no decimals. I don't care if there's 20 decimals. I want an exact answer, which means no decimals, like square root of 7 is left square root of 7. So I'm going to take this angle, which is not on the unit circle, and I'm going to double it. So I'm going to multiply it by 2. Well, that's going to give me the cosine of, well, the 2 and the 8 are going to cancel out and give me 4. So I got the cosine of negative 3 pi over 4. But I can't just, like, willy-nilly change the problem because I don't like what the teacher gave me. I still need to evaluate the cosine of negative 3 pi over 8. So that means I am not going to be evaluating negative 3 pi over 4, at least not as a final answer. I'm just trying to change the way this looks. So I've made this angle twice as big, so now I have to introduce a division of 2 to still, have the same value. If I take negative 3/4 and I divide it by 2 or flip up the 2, I'm going to get negative 3 pi over 8 again. So at any rate, now I'm looking at the cosine of theta divided by 2. See, I've set up a half angle, which means I can use a half angle identity for cosine, which is plus or minus the square root of 1 plus the cosine of negative 3 pi over 4 over 2. And if you don't know what that identity is, look in the back of your pre-calc or trig book, or look at the beginning of part 1 of my video and write yourself out a formula sheet. So we got plus or minus the square root of 1 plus the cosine of negative 3 pi over 4. Now that's a negative rotation, which means we're not going to go in a counterclockwise direction. We're going to go in a clockwise direction. And any radian measure on the unit circle with a denominator of 4 is a multiple of like 45 degrees. So it's going to be 0, negative 1/4, negative 2/4, negative 3 pi over 4. So the cosine of negative 3 pi over 4 is negative square root of 2 over 2. So plus negative square root of 2 over 2 over 2. So I'm going to find a common denominator for the top two fractions, which is going to be plus or minus the square root. This 1 is going to become 2 over 2. So it's going to be 2 minus square root of 2 over my common denominator of 2. That's all over a denominator of 2. And you see, once again, this happens so many times in pre-calc, where you have a fraction over a fraction. So we're going to take that bottom and flip it up, and the 2 over 1 is going to become 1 over 2, and our final answer is going to be plus or minus the square root, or almost our final answer, 2 minus the square root of 2 over 4. Now, so close to writing the final answer, so let's take care of a little bit of house here, clean up the house a little bit. Negative 3 pi over 8. What quadrant is that in? Now, we're evaluating negative 3 pi over 4, which is negative 1/4, negative 2/4, negative 3/4. So this angle that we're actually using in the identity is in quadrant 3. But negative 3 pi over 4, that's going to be in quadrant 4. That's less than 90 degrees. So I need to pick the correct sign for my angle that's in quadrant 4. And cosine in quadrant 4 is positive. So this isn't plus or minus just because the square root. There's not two answers. The answer is based off the quadrant that the original angle is in.
Shaker, please come to the main office.
The sign is dependent in the based on the quadrant the original angle is in. And again, negative 3 pi over 4, negative 3 pi over 8 is in quadrant 4. And that means that my final answer needs to be positive. Whatever. Now also, the square root of 4 is equal to what? 2. So this comes out to be an even number. So as a final answer, I'm going to be looking for the square root of 2 minus the square root of 2 over 2. Bam! All right, let's do another one. Alrighty then. So let's take a look at this one. We got a diagram. It's an angle in standard position. So let's pick a different color for that. It goes into quadrant 3. Here's theta. We've got a radius which is equal to 13 and a point on the terminal side that is labeled -12 y. And based on that information, I want to find out what the tangent of theta over 2 is. Okay, well, what do I need? If I want to figure out what the tangent of theta over 2 is, and picking the easiest of the three choices, in my opinion, tangent of theta over 2 equals 1 minus the cosine of theta over the sine of theta. So I need to take that information and find the cosine and sine of theta, which means I need to know x, y, and r. Well, I know r is 13. I'm going to come in here and set up a reference triangle. Reference angles are less than 90, and they measure the number of degrees or radians between the terminal side and the x-axis. So we have a hypotenuse of 3, or a radius of 3. We have an x value of -12, and the Pythagorean theorem, -12 squared plus y squared equals r squared, or 13 squared, is going to give me the answer of -5. That's one of our Pythagorean triples. Okay, awesome. Well, now I've got my reference triangle set up. I'm practically halfway done with this question. So we got 1 minus cosine of theta, -12 over 13, over sine of theta, sine, y over r, -5 over 13. Okay, two negatives cancel out to make a positive. We need a common denominator with that 13, so 13 over 13. And we get 13 plus 12 is 25. Over, common denominator of 13, over, -5 over 13. And whenever you have a fraction over a fraction, the denominators always cancel out. So when we flip the denominator up, I'm going to just cross these out because they're exactly the same, but they will flip up like I just showed you in a previous example. And not move up, flip up. And our final answer is going to be 25 over -5. So the tangent, these don't normally come out to be whole numbers, the tangent of theta over 2 ends up being -5. Sweet! Okay. Let's talk for a second, by the way, what quadrant is this half angle in? Well, the original angle, theta, is clearly in quadrant 3. So that means that theta is bigger than pi, or greater than or equal to, and less than or equal to 3 pi over 2. That means it's in quadrant 3, as we just said. If we're finding an angle measure that's half the size, that means that theta over 2 is going to be, well, what's half of pi? Pi over 2. And what's 1/2 of 3 pi over 4? I'm thinking of the answer, 3 pi over 2. If I take half of 3 pi over 2, I get 3 pi over 4. So my original angle is in quadrant 3, but my half angle is in quadrant 2. Now, we just got a trig ratio, a tangent ratio, which was -5. Tangent came out to be a negative number. Just making sure I got the right answer, or at least, you know, is it even reasonable that's the right answer? Well, if I'm in quadrant 2, tangent with the negative x and positive y's, tangent is negative in quadrant 2. My angle is supposed to be negative in quadrant 2. So it looks like we got the right answer. Let's move on to the next example. All right. How about the sine of alpha divided by 2? Or let's see what my time period is here. Yeah, we can do that. Okay, so the sine of alpha over 2, or theta, the half angle identity for sine is plus or minus the square root of 1 minus cosine of theta over 2. And here's what the identity is asking for. Cosine of theta is, as we have stated over here, negative 12/13. So let me just take that out and put in negative 12 over 13. So we need to, once again, have common denominators. These two negatives are also going to cancel out. So this becomes 13 over 13, so that looks like a B. And we get plus or minus the square root of 13 plus 12, which is 25, over 13, divided by 2 over 1. So that 2 over 1 is going to get flipped up, and it's going to become 1 over 2. And we have plus or minus the square root of 25 over 26. Now, that is reducible, so I'll do that in a second, but quadrant 3, we just discussed how our half-angle identity is in quadrant 2, and sine is positive in quadrant 2. So I keep writing plus or minus, but really since we're in quadrant 2, the answer is going to be positive. You only know that by evaluating what quadrant you're in, so just make sure you pay attention to that. And let's see what we got here. The square root of 25 is clearly 5. For 26, we got what? 6 times, actually there is no perfect square in 26, is there? So it's going to be 5 over the square root of 26, which is going to be 5 square root of 26 over 26 after you rationalize the denominator, and that's the sine of the half angle. Alright? Yep, alright, just making sure. Bam! Alright, one more example, and really quick, and we'll call it a day. For evaluating trig functions, in the next video we'll be doing proofs. The last example is like sum and difference angles. When they give you something straight off the unit circle or with numbers, it's probably because it doesn't work. Okay? Evaluate this using no calculator or giving me answers in exact form. That ain't going to happen because 112.5 is not on the unit circle. At least it won't happen in this form. But if you recognize the cosine squared minus the sine squared is your double angle for cosine, this is the cosine of 2 times 112.5, which is the cosine of 100 or 225. Well, the cosine of 225 is negative square root 2 over 2. Bam! I missed a true. Go do your homework. Or watch the video about the proofs.